On this part of math, we are going to understand vectors. What are vectors and how can we add them, and how can understand how we express the vector, and how we add them, how we subtract them, and what is the resultant vector of two vectors. Okay, for example, here, as you see, we have x and y coordinates. This is y and this is x. Good. And this point is 0 and 0. Okay, if I have a vector now that goes from 0 and 0 till the point here, for example, 4 and 3, it goes this way. You see, this is now a vector. As you see, its start is 0 and 0. So this is the start point and this is the end point. So this vector now, as it has one direction. So it has one direction. So it's going, as you see, from 0 and 0 till that point, which is point 4 and 3. This vector now, if I name the first point A, if I name the point A here, and I name this point B, so I can write this vector to say that vector AB. It goes, that means from the start point A to vector to point what? B. Or I can give it name, for example, M, so that I say vector what? M, vector M. And it can be written as you see here now, vector AB or vector what? M. Okay, also you can express this vector by its direction on the coordinates. You make this type of container, then you put a comma here and you write its x component. This vector now, it moved how many units in x? As you see, this one now is the x component, right, to 4. And this one now to 3 is the what? Is the y component of this vector. So it moved to this point that represent 4 and 3. So we can write this vector now by this component here. It means this is not like a parenthesis of a point. Okay, then you write here 4 and you write here what? 3. So this is what? Third way to express what is the vector. So you can name the vector, or you can say the vector as AB or vector M or vector what? 4 and 3. Also, you have another idea to say or to express this vector now. The direction on X, we call it I, and the direction on Y, you call it what? J. We call it what? J. So now I can express the vector now by saying how many units it moves on X. As it moves 4 units. It moves 4 units on X. So you say 4I. That means 4I. That means 4 units on X-axis. Plus, this is plus if it is positive. How many units on Y-axis? As you see on Y-axis, it's 3 units. So you write 3J. You see? So this vector now I can call it also vector M, that is 4I and 3J. So you express the same vector either by saying it's vector AB or by saying a letter and it's a vector M, you name it. Or you write it vector 4 and 3, or you write it what? 4I plus 3J. This is now how to express what? A vector. And we know that it has a point that it starts from and a point that it ends. So this one is start point and that one is what? End point. And for any vector here, it has 2 components. It has X component, this component, and it has what? Y component. It has X component and Y component. Okay, we understand till now just what is a vector when it goes from 0 and 0 to any other point, and how to express that vector. Okay, if I have this vector, by the way, just for example, if I have this vector, as you see, it has X component 2 units here, and it has here what? 2 units on the Y. What do I call this vector now if I want to name it this way? You see, in this case, what you do now to say X and Y, just move this vector to this point, to 0 and 0. Move it to the right. Move it 6 units to the right. Then as you see, it will be here. It will be exactly here as the green one. It will be from here, from this point to this point. You see? It will be this point. Then you write it what? As 2 and 2. as 2 and 2. So that means you can transfer, you can move a vector. You can move a vector left, right, up, and down. But when you move it, you keep its direction as it is, and you keep its length as it is. Okay, now we understand the vector now, and we understand the direction of the vector. As you see, you understand the direction of the vector. So this vector now, which is vector m, this is now, it represents its direction, how it moves on y and on x. But now if I give you a question, how long is this vector? Just a question, how long is this vector? This one now, this vector, how long is it? How long is it in units? How long is it? That means you take this y component and you draw it here. So you're going to have like a triangle, right angle triangle. Here is 4 and here is 3. So 3 squared, 4 squared, it's going to be what? 25. Then you take the square root, so that means it is what? 5. So that means I say that the magnitude of vector m equals 5. And the magnitude, it means what? The length of the vector. So any vector now, it has a magnitude. That means length, that it has a number as a length. Okay, then it has what? Direction. It has direction. So I tell you now 4i, 3j, just I'm giving you the vector as its components with its direction, but I'm not giving you here its what? Its length or its magnitude. To find its length or its magnitude for any vector, you find its x component and y component, you square them, and you take the square root as a Pythagorean theorem. And I hope you understand now how to find the magnitude of a vector and how to move a vector. That means you can move it, when you move a vector, you can move it left, right, up, down, but you keep its direction the same and you keep its length the same. So by keeping its direction and its length. And we say for any two vectors, we say they are equal if they have the same direction and the same length. That means the same magnitude and the same direction. In this case, we call them what? Two equal vectors. Okay, if we have now a vector here, this is now a vector that goes from 0 and 0 to 3. And I have a vector, another vector here, that it goes from here to 4. And I tell you now, what is the resultant vector of these two vectors? What is the resultant vector of these two vectors? This one, call it vector m, and this one vector l. Okay, what is the resultant of these two vectors? That means if I add them, what is their sum? What is the resultant vector? Okay, number one, what to do? First, you know that you have the right to move vectors, to move them. That means you can move them left, right, up, down, as you want. Now, when I want to find the resultant, I'll move one of these vectors, I'll move it, but when I move it, this one now, I name it vector number 1, and this one vector number what? 2. So when you start by vector number 1, you have initial point, which is a start point, and you have end point. So when you move now vector 2 to vector 1, make sure the start here of vector 2 will be on the end point of vector what? Of vector 1. So that means when you add them, when you move them, so that means I move this one here, so this point will come exactly at this point. So as long as I mentioned that one the first and that one the second, good. Then when you move this one here, when you move this vector, you make sure its direction is not a change and its length is not a change. So I'll move it now by blue color. When it moves just 7 units here to the right, so it will be here, and its direction will remain what? Will remain the same, you see. Now we have, this one is vector 2, which is m, as you see, and you have vector what? And pay attention, the first vector, its end point, then the second vector start point. So that means, look, the end point of vector 1 goes together at a point of the start point of vector, of the second vector. Now to write the resultant vector, I'm going to write it here with green. The resultant vector now, it starts from the start of the first vector. This is the first vector, where is it's the start here. And it ends where the second vector ends. This is where the second vector ends. So this is now, this one here is called the resultant vector, which is vector L plus vector what? M. So that means if I have two vectors, they are away of each other, I can combine them together in order to find its resultant. But when I put them together, I make sure that I can transfer any vector so that, as you see, in the initial point, only points, no arrows. And in the end point, there are two arrows. One arrow of the sum of the resultant vector and one vector of the vector what? 2. And here, as you see, have an arrow and a point, which is the arrow of the first vector, the end of the first vector, and the start of the second vector. This is now how to add two vectors, or how to find their resultant vector, how to add them. And I hope that is what? Clear. Okay, now, if I tell you now, vector, this one here, this is a point. This is a point, which is point 1 and 1. And this is a point, and I name it point A. And I have a point here, that is point B. As you see, it is point 3 and 4. And I tell you now, if I want you to connect these 2 points by a vector, it will be called what? Vector AB. Vector AB, that means it's the vector that it goes from A to B. It goes from A to B. Okay, how can I find the direction of that vector? So vector AB, it equals vector A, vector B, which is the last point, minus the initial point, which is what? Vector A. So what is vector B? What is point B here? It's going to be what? 3 and 4. Okay? You subtract them minus what? The point 1 and 1. When you subtract now, you subtract x minus x and y minus y. So 3 minus 1 is going to be 2, and 4 minus 1 is going to be what? 3. So this is now the vector, which is vector what? AB. So the vector here, AB, as you see, it is 2 and 3. What does that mean now? This vector now, 2 and 3. That means it moves 2 units in x, you see? And 3 units on what? On y. So it's 2 and 3. So to find vector AB, it's point, the final point minus the initial point. So it is B minus A. Keep that in mind. Many questions would come like that. What is vector AB? And it's different from what is vector what? What is vector BA? Vector BA, it's going to be A minus B. But here AB, it's going to be B minus A. So you understand now? If I have 2 points, what is the vector that connects these 2 points? We said it's final point minus initial point. Okay, for if I have 2 vectors now, 2 vectors 2 and 3, another vector which is 5 and 4. Can you add them? Yes. If you want to add them, okay, just you add x plus x and y plus y. So that is going to be 2 plus 5, it's going to be 7. And 3 plus 4 will be what? 7. So that means if you add 2 vectors, you add x component plus x component and y component plus y component. Even if it is minus, same thing. If you subtract 2 vectors, same thing. X component minus x component and y component minus y component. Okay, move now to understand just what is the unit vector. And to know that vectors in math, we study them as vectors, but then in physics or in other subjects in general, they represent vector units. They are vector quantities. Like force, we know in physics it is vector quantity, but time is a scalar quantity. So vector quantities like forces, we express them by vectors on what? On the coordinates. X and Y, or X and Y as Z if we have what? 3 dimensions. Here we have 2 dimensions, X and Y, but if we have like a cube, we'll have 3 dimensions, X, Y, Z. So that means we express also vector either by 2 dimensions or 3 dimensions, and this vector, it represents a quantity. It can be a force, it can be any other quantity that is what? Vector in physics or in any other topic. Okay, what is now unit vector? If I have this vector now, as you see, from 0 and 0 till this point here, this is now a vector. And this vector now, as you see, it has x component here. This This one here, it is called x component, means this vector, how many units it moved in x. And this one here, it represents what? Y component. That means how many units this vector moved on y. So this vector, as you see, it is 3 and 4. What does that mean? That means for every 3 units it moves in x, it will move also at the same time 4 units in y. So this is its direction, and both of them positive directions. The 3 is positive and the 4 is positive. So that means it is in the first quadrant, going like what? Like between the directions between positive x and positive y axis. Okay, now what is the unit vector? Unit vector now, which is unit vector. This is now a vector. What is the concept of unit vector, and how can we find it? Unit vector, it means, look, how long is this vector now? How long is this vector? To find its length, as we know, x component plus y component, when it's 90 degrees between them, then square root of both, right? So that means it's going to be 3 squared plus 4 squared square root. That means it's going to be 5. Good. This is now how long is it? So it moves now here. This one here, its length is 5 units. It's what? 5 units. So that means it moves 1 unit, 2 units. Like if I make them just smaller, it moves now 1 unit, 2 units, 3, 4, 5 units. These ones now, as you see, it moves 5 units. This is now, its long is 5. Its length is 5 units. Good. The question now, when I tell you what is the unit vector, it means if that vector moves only 1 unit, it moves what? 1 unit. What will be its x component for this unit, and what will be its y component? This is what does it mean, unit vector? Unit vector, it means give me this vector now when it is just 1 unit, when it moves 1 unit. Okay, how you find it? You find the vector itself. This one now, for example, is vector m. This one is called vector m. So you write vector m, and you write it over the magnitude of vector m. In this case, you find what? The unit vector. Okay, now, if you write it now, what is vector m? Vector m is what? 3 and 4. So you write it 3 and what? And 4. This is vector m over its length. How we find the length? As we know to find the length now, it is x component plus what? Plus y component, both of them squared. X component is 3 squared plus what? 4 squared. So that means it will give you what? Square root of 25. That is what equals what? 5. So you write here over 5. Now, if you split the denominator for both of them, you'll get 3 over 5, comma, then what? 4 over what? Over 5. Now, 3 over 5, it's going to be, as you know, 0.6 here, then comma, what? 0.8. Okay, what does that mean? That means now these numbers, now they mean as vector m moves 1 unit, it will move 0.6 unit in x, 0.6 here units on x, and it will move 0.8 units on y. So this is now what's called the unit vector. And it can be written this way. It can be written 0.6i plus 0.8 what? J, which is x direction and y direction. This is how to find the unit vector. We'll have many examples then to solve on them, how to find the unit vector, and what is the sum of 2 vectors, the resultant vector. And if I have parallel vectors, that means they have the same directions. If they have opposite, that means they have opposite directions. And in general, if I have the 2 vectors, they are on the same direction. If I want to find the resultant vector, I add them. But if I have 1 vector to the right, 1 vector to the left, like they are in opposite directions here, to find the resultant vector, you subtract them. But if you have 2 vectors that are orthogonal, as you see, they are 90 degrees. This is 1 vector and this is 1 vector. So to find the resultant vector here, which is represented by this vector, just you make them like a triangle, and you find its resultant vector by using what? Pythagorean. So if you can find the resultant vector, if 2 parallel vectors, we just add them. If they are opposite directions, just we subtract them. If they are orthogonal, that they make 90 degrees, just we find the Pythagorean theorem. Okay, we're going to solve questions related to these ones, and on the next video, That is for the next part of vectors. We're going to talk about how to multiply. Here just we add or subtract vectors and we understand the concept of vectors. And the second video you're going to understand what are the two types of multiplication and what's the difference between vector A times vector B or vector A times as a cross multiplication by vector B. Is this one the same like this one? No, this multiplication is different from this multiplication. This one is called inner multiplication or a scalar multiplication, while this one is called what? Cross multiplication. And both of them are different, and you're going to understand them in the next video. And pay attention, when you add two vectors, even if they have three dimensions, you add them with another one, same thing, you add these ones. If you want to find the length of this vector, you take the square root of x squared plus y squared plus what? Z squared. Then you take the square root of this vector. Thank you so much. See you in the next video.